Hi, everybody. My name is Katz. And yes, is my name. It's not a nickname. And I'm here to talk to you about JavaScript obfuscation. It's all about the packers. And as we move forward toward the end of the presentation, hopefully the meaning of the name of the presentation will make much more sense. And maybe we will decide to change the name of the presentation. We will see as we move forward. So let's start from the beginning, right? I will introduce myself shortly. As I mentioned, my name is Katz. I'm former OWASP Israel chapter lead. I work for Akamai. I'm a data-driven security researcher, which means, well, at least at my eyes, that I'm really focused on data, but I'm really focused with data to get security insights and more to that. When I try to classify what I do, always my goal, my objective is to take security challenges and turn them into science and solution space, to move them into the science and the solution space. And last but not least, I have very boring social network persona. Therefore, I will not encourage you to follow me on my Twitter account or _Katz. Really boring. I'm tweeting once every few weeks, and it's boring. Don't do that. I encourage you not to do that. So let's start the presentation. So in a sense, well, my presentation started over a year ago. In a sense, I was doing some research about JavaScript obfuscation. And I published 3 different blog posts in that context. The first one was more into different techniques being used to obfuscate JavaScript code. The second one was taking one very relevant example for obfuscated JavaScript and trying to de-obfuscate that given code, which is the picture that you see on the right on the screen. And the third one was to try to do some more of statistical point of view on the JavaScript obfuscation on the landscape. And when I was doing that research and publishing that, looking at that given example that you can see on the right, it took me quite some time to do that. It took me, a matter of skill set and a matter of resources and time to do the obfuscation. And I asked myself the question, can I do that in a much better way? Can I do that on very high scale kind of execution of that same thing or very similar to that? So that was my first objective. And the second objective in that context was to be able to take a JavaScript code and being able to identify that as being JavaScript code being obfuscated with a preferable kind of result that can enable me to say if that given JavaScript code is actually malicious, right? Obfuscation, well, and we will talk about it. Obfuscation is not always means something bad, and we'll try to explain that a bit more during the presentation. Now, the third objective that I had was to do that on static analysis kind of, looking into the data. And what that means, you can take JavaScript and do rendering for the JavaScript and then try to understand what the JavaScript is actually doing. But one of my objectives is not to do that for many reasons. And some of them are related to performance, and we will talk about that and try to better explain that later on. And my final objective, at the beginning of that research was to try to assume the Pareto principle. And the Pareto principle say the following thing: 80% of the outcome is a result of 20% of the causes. And in our context is, well, I don't try to solve the entire JavaScript obfuscation phenomena or the detection of JavaScript obfuscation phenomena. I'm trying to detect 80% of the cases that I consider them being created by 20% of the JavaScript obfuscation packers. Right? Packers are the software that will take a JavaScript code and do a obfuscation of that given code. So that's my assumption. I'm not trying to detect all the coverage that we have out there for JavaScript obfuscation, only part of that. With that in mind, a few questions that crossed my mind. First question was, why and how JavaScript is being obfuscated? And we'll address that in the following slide. The second question that came to mind is, what are the numbers out there, right? So I'm into the, goal of trying to detect JavaScript being obfuscated in the wild in scale kind of capabilities. But the question is how that JavaScript obfuscation phenomena is widely used in the wild, right? So that's a question that I had in mind that I wanted to address, and we will answer that. The third question that crossed my mind was, so JavaScript obfuscation, does it always mean malicious or not? So the spoiler for that, and I assume that most of you or some of you are familiar with that, is that obfuscation doesn't mean a bad thing, right? But we'll go over that and see some example and try to better understand once JavaScript is being used in the wild and it's not malicious, what are the use cases and what we are seeing out there. And the final question was, is it possible to detect JavaScript obfuscation, right? And we will go over that and we'll try to figure out how to do that from a technical point of view. And following to that, we will also try to address, some of the questions that well, as I said, I created some spoiler for that. We know that not always JavaScript being obfuscated means something bad. Therefore, can we differentiate between JavaScript that was obfuscated and means something good versus something that means something bad, meaning malicious in that context? So this is part of the thing we're going to cover today. So let's start from the first question, right? Why and how JavaScript is being obfuscated? And to try to better understand the why, we need to discuss JavaScript, right? JavaScript is a client-side code, right? It's a code that is being exposed to the end users, being executed in most cases on our browser. And once being executed, we actually know what the code is supposed to do before it's being executed because it's visible to us, as opposed to server-side code, right? And in that context, that can explain why JavaScript is being obfuscated, and regardless if it's for a good reason or a bad reason, right? Regardless if you are trying to obfuscate a legit kind of code or you're trying to obfuscate a malicious code. Because if someone wants to make sure that it will be hard for you to understand what that code being executed on your browser is doing, you will try to obfuscate the code and try to make it much harder for you to try to understand the context of the code, the functionality of the code, and what the code is actually executing. Right? It's not impossible, but it makes your life much harder to understand once someone is doing that. Now, in order to do that, it will probably create a code that is unreadable, undebuggable. And when you think about it in the context of malicious code, or even in benign code in many cases, it will create a code that is obfuscated because it will evade a variety of detection techniques that are using text-based or hash-based detection capabilities. So it could be someone that created a code that it doesn't want, for example, search engines to see what this code really represents from a textual point of view. So we will do an obfuscation for that. You can imagine, for example, we will see one of those examples, an email address. If someone contain an email address in the content of the page and you want to obfuscate that, you might use JavaScript obfuscation to try to hide it in that context because you don't want search engine to find that kind of information, or just internet scanners or variety of bots that scan the internet. Now, from a malicious point of view, if someone create a polymorphism kind of code that constantly change, if you try to track that code by creating signatures that are text-based or hash-based, obviously detection will not work because the code is the representation of the malicious code is continuously changing as we create new samples of an obfuscated code of that same malicious, originally malicious code. So this is the why, right? And how? Well, there are a variety of techniques, and I will go over 3 of those that are, well, the most popular and the most, common being used. So you can create in order to create an obfuscated code, you can create a code that is repetitive or meaningless in the context of the function names, in the context of the variables that are being used. And once you are doing that, that makes the code unreadable and in a way undebuggable. You can use an anti-debugging code techniques in order to make sure that if someone will try to debug your code, it will be harder for him to do that, right? It's not impossible, again. At the end of the day, it's code that is being executed on the client, and therefore it's always possible to do that, but it's make your life much harder to do this once someone is putting more traps in that code. And finally, well, using a code that is doing computational kind of resources and time exhausting, meaning running dead code that just being executed without any meaning, which will create much more time for the page to be rendered, or putting timers into the code being executed will create a situation where a given code will take much more time to be executed, to be rendered. And as a result of that, will create some issues from a performance point of view. And this given item is actually related to one of my objectives from the beginning, when I said that I don't want to create a solution that has a performance issue, therefore I'm not rendering the page. So that was my incentives from the beginning. Now, how the story starts, right? So I told you at the beginning that a year ago, I was looking into some JavaScript code and was doing some publication around that. And while I was doing that, I was seeing 4 different examples for JavaScript code being obfuscated, right? The 4 examples that you see on the screen. So this is a part of the code. This is one function being taken from different samples of code. And when you look at that at the first glance, you can say, hey, it's not the same, right? It's different. But if you take a second glance on that given code and you do zoom out, you will see that actually there is some pattern here that repeats itself in a sense, right? But I will tell you, hey, it's a different code in the context of, well, the meaning and the context of the code being executed. Because those 4 different examples representing the 2 upper examples are representing phishing examples, one for a bank and one for some social networks. And on the bottom, you can see on the left side, it's mage card kind of JavaScript being obfuscated. On the right side, it's a malware dropper being obfuscated. So wait, it's different samples of code that we say that they look a bit different, but we said that they look a bit the same, right? The same pattern, but they're actually different because they are actually executing a different kind of threats using different kind of functionality of JavaScript to execute, different kind of, threats to the clients. But what we're seeing is it's an obfuscated function being used by the same packer on those 4 different examples. And this is the pattern that I was looking for, right? It's an anomalous JavaScript function that has a variable that variable contains a name of the function, well, a function in a sense, and that function is doing a while in a decreasing kind of way on an integer that was supplied to the original function. And inside that while, we're doing some reshuffling of one of the parameters that was originally supplied to the upper function, doing some shifting and pushing, meaning doing some changes of that given array being supplied, the elements of the order of the elements of that array. And that is actually the return value of that function. So that's a classic obfuscated function being executed by a given packer, right? So now comes the question. So we understand that there are the same threats, or well, different threats being used using the same packer to do the same functionality of obfuscation. Now the question comes, so can we actually detect that pattern, right? We don't want to detect the name of the variable. We don't want to detect things that are constantly changing as we saw before, but we want to detect the given pattern of the functionality being executed. So in order to do that, what I was doing, I created a proof of concept for that. And in that proof of concept, what I was using is an AST kind of representation of JavaScript code. AST is an abstract syntax tree. It takes the given code, it will create a structure for that code. And if you can see on the left side, that's one of the examples that we see the page before. This is on the right side now, you can see that the representation of that in AST, right? So it's a structured kind of way to represent some of the code being executed. Now, if we will try to think on the pattern that we were looking before, right, without the variable name, without things that might change from one implementation to the other, just the functionality. So when we look on the AST tree and we will look on specific places, we might ask ourselves a question, do we see a structure that has a function and that function has a while statement and it's a decreasing kind of while statement on an integer? And can we see some pushing and shifting of a given element in an array? So that's the way for me to, that was the way for me to take the concept of trying to find patterns of obfuscated functions or obfuscated packers and try to implement that. And that's the proof of concept that I created. I'm taking a JavaScript code, I'm doing an AST representation for that. I'm running on that, looking for the pattern that I'm, was able to create. And if I'm seeing that, I'm actually matching the detection, and I was doing that in Python. So that's the concept, and that's the technique for me to detect those kind of signatures, right? Those pattern-based signatures of obfuscated code. And I was doing that for 5 different packers, JavaScript packers, right? And here are the 5. Well, you can see 3. The other page has another 2. So the first 2 are actually a basic ones. Both of them are doing decryption or unescaping of values, which are really, really basic from a obfuscation point of view. They're not really complex. And most of them, at least the second one, I knew that it's an old one that mostly being used for phishing websites. The third one the third, the fourth, and the fifth are actually, they are different, but they are the same. They're different because it's a different implementation, but they are the same because all of them are actually doing some sort of a manipulation of a given payload. Someone is providing a payload, and those functions will try to do some splitting of the data, doing reshifting or changing the order of the data, doing some padding or adding, some encoding mechanism on the given data, base 64 or URL encoding kind of decryption. So that's the first. Those are the 5 different examples, 5 different examples that represent 5 different packers that I decided that I want to focus my research on those examples and those examples only. And I gave each of those different packers a name. Actually, I was doing that a bit randomly. As you can see on example number 4, which is called packer, right? With a dash between the letters. So I decided to do that because once you call that function, the name of the variables or the parameters being delivered to that function are PACKER, which represent packer. And that's how I named that given packer that I'm trying to find a way to detect it in the wild. So we have that functionality. We have, the proof of concept of taking a JavaScript page, being able to do some parsing of the page, being able to run on that parsing and match some signatures that I created for 5 different packers, JavaScript obfuscation packers. Here's some of the results, right? We need to verify that we're doing the right work here. So on the left, you can see the 5 different packers, and you can see that the first data set that I used was a phishing website, phishing data set of over 100,000 URLs. And I was able to see that there's really decent result for that, meaning the assumption that I created a pattern-based detection for obfuscation functionality representing different JavaScript packers created some result, nice result from my point of view. And I was doing that on a malware data set as well, with even better result in terms of the number of hits that I was able to see. But it's more than that, because those 2 data sets represent something malicious. I wanted to do also the other side, which try to see if those same functions, that same proof of concept can also be executed on data that is supposed to be legitimate, right? And in order to do that, I used Alexa ranking 18,000 top most ranked website in the world. And the interesting part is that I started to see hits on those websites as well. And I was doing that also on a random data set of domains that in that context, they are not they are not highly ranked as opposed to Alexa, and they're representing something more spread from a popularity point of view. And I was able to see very similar hits to Alexa being done on that data set as well. So these are the numbers, right? The percentage of detection of each of those data sets. And you can see obviously that those that are classified as malicious have the, hit rate much higher in terms of percents versus those that represent benign data sets. And I was doing some, trying to figure out what are the insights that I can take from this data. What's the interesting part here? And I was doing some, analysis of that. And what I was able to see, the first conclusion, which is a good one, which means that the technique that I was using, the JavaScript obfuscation and detection, is accurate. Or in other words, I was going into the Alexa and the random data set and try to see if there is, for example, matching there for the pattern that I was looking for, that pattern is for, reason that I cannot explain, represents something that is not that given obfuscation techniques that I was looking for, okay? And in that sense, once looking into those, I was able to see that those hits were actually representing an obfuscation techniques, the same obfuscation technique that I was looking for, but they were hits on the benign data set that I was using. Or in other words, what we can learn from that is that obfuscation is obviously not being used only for malicious content, it's also being used for a benign content, which is an interesting thing. Now, the second part, that the second insight that I was able to see is that I had really good result, right? I have over 4,000 different new phishing and malware URLs or domains in the context of this exam that are actually being detected as running obfuscated code. And in that sense, it gives me an advantage because one of my goals is to be able to do that on scale, to do that kind of detection. And it's important to say that, well, once you try to do that in techniques, as I mentioned before, those that are using text-based or hash-based detection that were obviously failing in the context of JavaScript being obfuscated, in the new technique that I just introduced, they are actually being detected correctly, and I can see those hits, and I can actually create some detection that I didn't have before. Now, a few more interesting things. We can see that some of those packers are actually associated with malicious activity. For example, the AES decrypt function or the Katz, which are mostly being used for phishing attacks. And that's interesting because that means that if I will detect that kind of activity, that kind of an obfuscation activity, according to this data set, I can assume that it's malicious, right? It doesn't have implication on benign kind of data set. Therefore, it can be a strong indicator for JavaScript being obfuscated, but more than that, it's malicious. And finally, as I said before, what we learn from here is that obfuscation is different than malicious, right? There's also benign usage for JavaScript being obfuscated. So that's interesting, right? So a few questions that come after that, right? The first question is, so we talked about benign website, well, legitimate website that are being obfuscated. So the first question that comes to my mind is, so what does it mean? Why those websites are actually trying to obfuscate some of their code? And I look into that. So that's the first question, and soon we'll see the answers. The second question was, okay, so, well, we understand that obfuscation is different than malicious, well, meaning obfuscation can also represent benign. So how can we differentiate between something that is obfuscated and it's benign versus something obfuscated that is malicious? And that's the next step for us to do. So as I mentioned, so we know that some of those benign examples of domains that were sampled are actually representing, using obfuscation technique. And I asked myself, so why it's being done? So here are a few of the answers for that. First of all, as I mentioned at the beginning of the presentation, email addresses, for some reason, some websites decide to do some obfuscation for that and make those email addresses not being visible if you look into that without doing rendering to the page. And this is their way to try to evade, variety of scanners or search engines or, whatever bot we see out there trying to harvest those kind of email addresses. Again, I don't agree that that's the right approach, but that's what they were doing. I was able to see a variety of cookie client-side functionality being obfuscated. Again, I'm not sure it's the right or the relevant thing to do, but that's what those websites are doing, trying to obfuscate their code, trying to make it to create some security by obscurity in that context. Many examples for third-party scripts being obfuscated, scripts for advertisements, scripts for doing translation of services. You can think about it like that. Let's say that I'm a third party, I create some JavaScript code that is supposed to be integrated into a variety of websites. I might decide to do some obfuscation for that code to make it unreadable or not well understood to those that will look at first glance into that code. And again, it's security by obscurity in that context, but that's something that happens in the wild, and that's what we are seeing here. And last, well, was adult content that is, well, in a sense, a grayish area kind of, websites that has a lot of, issues with them that related to security. And obviously, for some reason, well, not obviously, but for some reason, they are more using those kind of obfuscation into their code. So we talked about what are the examples that we see out there. Then comes the question, so how can we differentiate that? How can we take a given JavaScript code that was identified as being obfuscated and try to differentiate between the benign use case and the malicious use case? And in order to do this, I will use a technique that has two approaches, approach A and approach B. Approach A will try to do allow list. Approach B will try to do the block list. Now, what does it mean? Let's talk about the allow list. So what I was doing, I was saying, okay, so let's take all the benign data that I have, which means the random and Alexa data set. And I was doing some sort of a pivoting around three different elements. The blue element, the blue circles that you can see here, is the domain names. The orange one is actually the hash value of those JavaScript code being obfuscated, right? And the grayish one, the bigger one, are representing Alexa and random. So in a sense, what I'm showing here is very similar to the third-party example that I mentioned, is that once the same code that was supposed to be integrated to many different third-party code, that is supposed to be integrated to many different websites, is being used in the wild, we are starting to see some relationship between them. And that relationship can help us to take it to the next level and say, let's try to create allow list that will tell us that, yes, if we see that given code, that it's an obfuscated code, but we are familiar with that code because we were able to profile that code as being used by many different websites out there that has really great popularity ranks or something like that. That by itself can reduce 20% of the problem, meaning out of the nearly 240 domains that I was able to see that are hosting, that are benign domains, that are hosting obfuscated JavaScript, 20% out of them were actually solved, were able to solve them and try to classify them as allow list because I can see a reuse of the same functionality, same JavaScript functionality being used by those different domains. So that was the first step of the approach, which we call it the allow list. The second part of the approach that I'm trying to suggest is an approach that is based on machine learning. And the basic concept is the following, right? Let's say that I can see a JavaScript that is being obfuscated in that context. Now comes the question, can we pull up some features out of that JavaScript code that will enable us to make more decisions based on those features? Maybe those features will enable us to differentiate between benign JavaScript being obfuscated versus malicious JavaScript being obfuscated. So a first example for such feature would be array kind of object being used in the JavaScript. And many of those functions are actually taking arrays and put the payload inside that array. So feature would be, for example, number of elements in the array, the length of the elements, what kind of characters are being used as part of those elements. Can we see some prefix of encoded kind of values being used there? So these are, for example, some example for features. Different kind of feature could be, for example, the identifiers or, identifiers that are being used as part of that JavaScript code. Like identifier could be variable name, function name, any name convention that happened in that page. So if we can, for example, count the amount of identifiers being used, or maybe we can say, hey, if we see identifiers that start with _0x, which you can see on screen. That's a very common kind of technique being used to try to create a code that is not readable. Maybe that's an indicator. Maybe we can count those numbers, and those numbers will enable us to make a better decision, again, between benign and malicious. So here is an example of plotting of two of those features that I decided to use, right? And in order to better understand, I was deciding to focus on a very specific packer, the push shift packer, because I was able to see that that given packer is being used for both benign and both malicious kind of use cases. And I plotted two of those features. On the left, on the Y's, you can see the number of unique identifiers. Number of, well, as I mentioned, identifiers would be variables name, functions name, array names, those kind of, those things, those objects are represented identifiers in that context. And on the X's, what you can see is the number of elements in array that I was able to see. And first look on that graph give us pretty good answers. And why? Because we can see that there are different classification, very easy classification that can enable us to make a decision. The most right rectangle and the most upper left one actually representing two groups that represent just malware activity. And as a result of that, if we can use those features, we can easily be able to identify JavaScript code that is being used and has the relevant numbers associated with those features as something being classified as malicious. But we're still having some problem because we can see that in the center of the graph, we have values for both benign, in other words, Alexa, random, and malware being mixed together. So we want to better look into that. So I zoom into that, and what we can see here is we still have some ability to do something here because we still see that there is some differentiation here when it comes to the values for those features in the context of benign versus malicious. So this is a graph with two features being used. Think about it from a machine learning point of view. If you use many features, that will enable you to take even that small group and try to differentiate it between benign and malicious. And this is what I was doing. I was doing, for the sake of experiment, the usage of three different features. The first one is number of identifiers, starting with _0x. The second feature was the number of elements in an array. And the third one was the number of unique identifiers I was able to see on a given script. And I created a decision tree based on a random forest algorithm that I was running. And when I was looking into the right path on that tree and try to better understand what this tree can help me in the context of being able to identify between something that is benign versus malicious, what you can see is that if we will take those three features, we'll ask number of _0x identifier bigger than 20, and well, on a given script. And on that given script, we can also see that there is an array with over 17 different elements. And more to that, there are unique identifier greater than 92. Only that path on the tree will enable me to solve over 750 of the samples that I was able to see and classify them as malicious. And by that, eliminate some of the problem that I was having, and in that context, try to better explain and understand how a machine learning module can help me make a decision based on some of those features that we were able to classify. So in that context, we have an approach. We build something that we can do some detection. We know how to detect JavaScript that is being used in the wild and represents something that is obfuscated, JavaScript obfuscation being used. We were using some technique to try to differentiate between benign and malicious. Now, how can we use it in a more practical kind of way? So our first approach would be to implement, well, the technique that I was just showing you, right? The core functionality of detecting JavaScript being obfuscated. and then building some module that is based on the allow list and the block list and try to better understand if we look into a given JavaScript, whether it's malicious or not. That's one thing to do. A different thing that we might want to do is, we'll try to use the core functionality of identifying JavaScript being obfuscated and use it in the context of our website. For example, if we look into our website and scan the website and see that there is no JavaScript, obfuscated JavaScript being used on the website, and suddenly we're doing another scan of that kind of website and find an example of something being obfuscated, that by itself should, alarm us and should take us to the next step of trying to better understand what's the reason the code is there. Is it a legit third-party feed that was integrated? Is it something that was injected to the website, a mage card kind of scam? So that's another use case that we might want to use. A different approach would be to enrich some of the data that we have with other indicators. For example, if you can see a JavaScript code being obfuscated, we can also ask ourselves, what's the age of the domain? Is it a newly registered domain or is it an old domain? Newly registered domain that has JavaScript being obfuscated in it. My assumption is that most likely, right, it's not a Boolean decision. Most likely, the chances that that website contains something malicious is much higher than expected. A different kind of indicator can be popularity of the website. If a website that is highly popular has some JavaScript being obfuscated, well, it could be benign scenario. If it's a website that is not highly popular, maybe we can make a decision based on that. Maybe it's not the right decision, but maybe it's a decision that we can take. Meaning, if some website is not really popular and I can see JavaScript being obfuscated, even if it's not malicious, blocking that website will not be something so dramatic from a defensive point of view, right? So this is some of the approaches from a realistic or practical point of view. Few of the questions that we had at the beginning, right? We had 4 questions: why and how JavaScript is being obfuscated, and we covered that. What are the numbers behind the usage of JavaScript in the wild, JavaScript being obfuscated in the wild? We saw numbers related to that as well. We answered the question that we actually answered at the beginning, but we actually explained that a bit more in depth around JavaScript obfuscation and whether that represents something malicious or not. And last, we actually talked about the different techniques that we can use in order to identify JavaScript being obfuscated. And more to that, we took it into the next level of trying to differentiate between benign and malicious JavaScript. So what are the next steps for me, right? Because I'm not done yet. I want to release the code. I'm not there yet. I need to still work on that. Hopefully, I will do that in the following month. Maybe add another signature for additional packers. I use only 5 in this experiment. While doing that, I was able to see more packers, like looking into the data, and was able to see some of the things that I was able to miss. And I acknowledge that those are packers that I didn't create a signature for those packers from the beginning. So maybe adding those. Refining some of the data that I was doing, more rich data, more if more volumetric data might result with a bit different insights that I want to do, that I want to have in that context. Add more feature to the machine learning algorithm in order to have better decisions based on, to have better detection in the context of looking into JavaScript code being obfuscated, and we want to make sure that we are making the right decision, know how to differentiate between malicious and benign, and as much feature as you take, well, it's not always that, but taking the right features that represent the ability to better detect is something that I need to do some more work around that. And last, the ability to create maybe the capability of actually detecting those patterns, right? Those 5 different packers that I used, I was discovering the pattern manually. Now comes the question, can we do that automatically? Can we go over some code and try to figure out if there are some patterns on that code representing something very unique to JavaScript obfuscation packers that can be used in that context? So at the beginning, I told you that the name of the presentation is all about the packers with the dashes between the letters. And I, during the presentation, explained what's the reason for that. It's one of the functions that I was able to see, right? And you can see that example here. And the interesting part is that while I was doing that, I was telling myself, hey, I cannot use those variables as an indicator for that given functionality, that obfuscation functionality being used in the web. I want to ignore them. They are not relevant. And I was doing the right decision because as I was doing that, suddenly I was able to detect another variation of that same functionality, of the same obfuscation functionality, but this time using, instead of packer, using the letters representing packed, right? Good for me. But as I continue, I was able to see another example using something entirely different, again, using the same functionality from an obfuscation point of view, by using different variables to that functionality, representing something that starts with _0x, right? And therefore, I thought to myself, maybe I should change the name of the presentation to something that you can read at home, and I don't want to read it now. That's just hopefully a funny anecdote. I think I'm done for today, and I'm available for question. So let me just go to the relevant place. Looking for some questions. I don't see any given questions out there. If there are any, please let me know. And we'll wait a few minutes and we'll drink some water because I need it. If no question comes in, so feel free to reach out to me, DM me. I'm here to answer your questions. I think we are done for today. Thank you very much, everybody.